In Digital Geology, we bring the geological field trip into the office environment, using exhibits of real geology like rock slabs, cores and fossils. We combine these with digital overlays to provide hands-on reservoir characterization analysis underpinning key upstream business decisions. This is done at various scales of geological analysis, ranging from basin scale to grain scale, each with their associated workflow and related upstream decision. Let me take you on a virtual tour along the various digital geology exhibits at Shell's Learning Center in Rijswijk in the Netherlands. Let's start with the basin scale exhibit. At this scale, exploration geologists analyze the geological evolution of large sedimentary basins through time and the associated processes of hydrocarbon formation and trapping. For this, global datasets and plate tectonic reconstructions are used which show the development of depositional environment and plate movements through time, which are crucial for the understanding of the development of petroleum systems and the formation of hydrocarbon reservoirs. Once a basin has been identified, we zoom in further to the play scale, at which we try to assess the various play elements like the presence of hydrocarbon charts, reservoir development, as well as the presence of seal and structure, in order to arrive at the play map that defines how and where a play is likely to work. This could underpin the decision to acquire new acreage, for example, or to drill an exploration well. Once an exploration well has been drilled, the newly acquired data, like well logs, cores and fossils, are integrated with the seismic data at the environmental scale to interpret the depositional environment, as this governs the overall reservoir architecture and therefore the fluid flow in the reservoir. A range of conceptual geological models are constructed that provide guidance on what type of field development would be appropriate and whether further data acquisition and appraisal is required in order to arrive at a robust investment decision. Once an economic field development has been established and more well data has been acquired, it becomes important to predict in more detail the reservoir architecture and fluid flow away from the wells to optimize field developments. This analysis is done at the FACIES scale exhibit, for which a dedicated, fully cored research well was drilled together with the University of Barcelona and Schlumberger. The acquired core data is linked through augmented reality with log data as well as core description and interpretation results for subsurface uncertainties to be captured in a range of 3D subsurface models that underpin the field development decisions. Once a field has been in production for some time, there are later field life decisions to be taken, such as the choice of secondary and tertiary recovery scheme. This requires a thorough understanding of the composition of the pore network, fluid properties, reservoir heterogeneity, as well as porosity and permeability distributions. This analysis is done at the grain scale, at which small-scale heterogeneity can be analyzed on both clastic as well as carbonate rock slabs. Finally, the results of the analysis at the various scales can be visualized and integrated in Shell's virtual reality center, the ISCOPE. In this collaborative environment, multidisciplinary teams can come together to jointly interpret and discuss the outcomes of the various analyses to arrive at a common understanding underpinning effective business decisions. The digital geology concept has proven to be an exciting, new and innovative learning approach for our young professionals. It also serves as a platform that promotes collaboration between the various disciplines within the company and provides a permanent exhibition of subsurface workflows and technologies. The next steps are to acquire additional digital outcrop datasets like drone footage and panoramic photographs to be included in the exhibits, further enhancing the virtual experience. Watch this space.